Welcome to Citizen Science, stories of science we can do together. Coming to you virtually live from SciStarter's virtual world headquarters. In this episode, we'll learn about some of the citizen science projects operated by the National Oceanic and Atmospheric Administration, NOAA, and how you can get involved.
Hey, Bob.
Hey, Caroline. Nice weather we're having, assuming you're, a meteorologist, and nice means kind of crazy. It's the middle of winter here in DC, and I was out in my t-shirt catching some rays one day, and then we got a foot of snow.
Weather has definitely been unexpected this winter. While they're having winter tornadoes in the middle of the country, there is some record-setting snow out west. Mm-hmm. Our friends at the National Weather Service definitely have their hands full keeping up with it all.
Fortunately, though, they don't have to do it alone. There are tens of thousands of citizen scientists diligently measuring weather conditions every day and reporting their data. The National Weather Service has been relying on contributions from citizens since it first began 130 years ago.
So, the National Weather Service is the part of the federal government that handles the science behind weather broadcasts, warns about dangerous weather, and takes on all sorts of weather-related work related to public safety. And they're just one part of NOAA. NOAA does weather-related work, they monitor the seas, they protect endangered species, they support environmental literacy work, and so much more. I know, it's amazing. There are tons of citizen science efforts at NOAA, and today we'll be learning a little bit more about them. Fun fact, did you know that SciStarter has worked on a few NOAA-supported projects?
Really? That must have been before my time. Like what?
It's ongoing, actually. I will tell you more. In partnership with museums and science centers across the United States, and with support from NOAA, SciStarter has worked to create microsites where you can find spotlighted citizen science projects and other activities like forums that correspond to different environmental hazards like extreme heat, extreme precipitation, and more, all highlighted on scistarter.org/NOAA/NOAA.
Wow. So there are all sorts of ways you can get involved with citizen science to, monitor weather, address environmental hazards, and help track the changing climate. You can even analyze NOAA data that other citizen scientists have collected.
To get a broader overview on NOAA citizen science, our first conversation is with Katie Palubicki, Outreach Coordinator at the NOAA National Centers for Environmental Information, or NCEI, and Trinity Foreman, her colleague and a communications consultant.
Hey, Katie and Trinity, could you introduce yourselves and tell us a bit about what you do?
Sure, yeah, absolutely. So I am Katie Palubicki. I am an outreach coordinator with NOAA's National Centers for Environmental Information. And my role is to do a fair amount of communications work. So that's reaching out to the general public, writing web stories and social media plans that tell the general public about our science and kind of take really technical concepts and break them down into something that everyone can understand. So that's my primary role. Another part of what I do is I work with what we call our customers, is folks who utilize our data and kind of understand what their needs are and how we can help meet those needs better. So whether it's a different type of data or, a different file format that they need or something like that, a lot of my role is also connecting with those folks and really determining what it will work best for them so that we as an organization can better serve their needs in the future.
Great, thanks. And Trinity, how about you?
Yes, definitely. My name's Trinity Foreman, and I work as a government contractor with ICMS at NOAA's National Centers for Environmental Information. And I work alongside Katie, but I do a lot of, my title is communications consultant. So I work a little bit all over the place with making content for social media, but I really specialize on getting our data resources in a format that's accessible to teachers and educators and getting that data out into the hands of educators.
So what sort of data does NOAA collect and archive?
Oh gosh, there is so much data in our archive. We usually say we collect data from the surface of the sun to the bottom of the ocean. So it's a very thorough and complex collection of environmental data. And really, our users span a great variety. So we get requests from students in elementary school working on projects to scientists at some of the biggest research institutions writing papers and doing research on environmental issues. So there's really a huge span of users for our data, and we try to make it as accessible and usable as possible for all of those user groups. So, a fifth grader will be able to use our data, but so will a Harvard professor, which is really neat.
Can you give us an example of how citizen scientists can contribute?
Sure. So I can speak to CrowdMag a bit. CrowdMag is a phone application that uses the magnetometer and within the phones of all of smartphones that we have. And that app really sets it up so that that data that you really walk around and collect without realizing goes into our archive and informs things like the world magnetic model. So with the phone app being programmed to collect that data, it really, wherever you are, and if you have a phone, you're able to directly collect data and have it go into the archive. And there is some checking of the data to make sure that it's, quality and able to inform our science, but that's really the pathway. So you don't have to have a license, a master's, a doctorate, or anything like that to contribute to worldwide how we understand the magnetic model, which is our understanding of the magnetic sphere of the Earth.
I thought I was smart. I never heard of the world magnetic model.
Yeah, it's an international tool for understanding how magnetism works around the world, and it informs things like your GPS in your phone, and also helps with navigation in airplanes and things like that. So it's a really important tool, and it gets regularly updated, and things like CrowdMag help inform our understanding of it.
And how about all the weather data that you collect? We're going to be talking with a group involved with that later in the podcast, but what can you tell us about how that sort of weather data gets used by the public?
Well, I will say that there, in a different department of NCI, there are our customer service, which actually Katie is involved in. They deal a lot with these really unique requests, and we actually get to hear about them internally. And you have things like people having their tractor explode, and then they need to go to insurance to figure out if there was a lightning storm around there to claim it, as that's why, it's a very interesting one case scenario. They need to prove that to their insurance company, but they use our data to inform that. And things like certified weather reports can help with that. But I don't know, do you know of any more off the top of your head, Katie?
Gosh, I know. I feel like I'm under pressure right now to think of all of our really cool requests that we've gotten in. We do get a lot of requests from teachers for lesson plans. A lot of teachers are really interested in our tsunami and earthquake, our natural hazard data. We have set up quite a few resources that kind of visualize that data, and is really easy to use in the classroom. And actually, Trinity could probably talk about that a little bit more. But that's one thing that's been really popular. I know folks have used, just our bathymetry data was recently used to construct a kind of a scale model of Lake Michigan for a museum. And that's pretty neat to see. And so kind of taking the data and actually having some real world application of it is always something that's really cool for us to see and interesting.
Now, if there's a news event or something like, I know the solar flares that happened recently, do you then see a spike in interest in that topic?
Oh, yeah. Oh, absolutely. Anything timely, anything newsworthy, we usually end up with a spike in interest. And we do try to be on the ball about that. So recently, there were some solar flares that caused an aurora in, the lower United States, lower than normally would happen. And so when we found out about that, we worked with our partners at the Space Weather Prediction Center to find out that was happening. And then we posted on our social media channels that, keep an eye on the sky, the aurora is coming. So we tried to stay on the ball and get a good pulse of what people are going to be interested in and what's really valuable to the general public. And those things tend to do really well on social media. There's a lot of engagement. We do a lot of conversation with our data users about that. So that's always an exciting thing to see.
So how do people gain access to this wealth of data?
Absolutely. I'll chat a little bit about that and then let Trinity talk about the best way for students to access it. On our website, it's pretty user friendly for the most part. If you know what kind of data you're interested, let's say it's bathymetry data or it's weather and climate data, our website is split into products that break down, here's weather on this historical day, and you can go and check that out. So there's always the option to just kind of choose your own adventure and walk through our website on your own and find the data you need. Another option is to email us directly. We have customer service representatives that are always more than happy to help. And if you email us at ncei.info@noaa.gov, somebody will get back to you and help you access the specific data you need. And even in some cases, we can connect you directly with the scientist who manages that data or who even collected that data and really give you a great resource in your interests.
Yeah, and also, if you're interested in having a kind of general understanding of our data, we on our website at nci.noaa.gov, under the resources tab, we have a tab for education where we've taken some of our more accessible data tools and framed them so that they're easy to understand. And we have one for tsunamis, we have one for bathymetry, and it introduces some of our data resources with some hands-on activities. And most recently, also our news section on the website, we do a good job of summarizing upcoming updates and about our resources and making sure that people know about them. But very recently, we released a teacher guide and a worksheet for our tsunami animation. It's a time lapse of all the tsunamis that have happened on Earth. It's really fun for anyone, really, where you can scan back and forth and see the tsunamis as they happen, and in this digital scape. And then we've taken that and introduced it in a way where it is more accessible for teachers to bring into the classroom, because there's a big push in classrooms to bring real data into the classroom. So finding ways like that to really have the data be engaging and exciting and something that's useful and relevant is really a goal of our educational resources that we try and make.
I think my final question would be, is there anything else about the archive that you haven't told us yet that you think people should know?
I think, one thing that is really important to understand is that data feels very daunting and unapproachable. And we've worked really hard at NCEI to develop products and maps and resources that make data interesting and fun and accessible for all ages. So even if you think you're not going to understand the data or understand the science, we've really worked hard to create products that will help you understand it and makes it very approachable in a fun way.
Great, thanks. Thanks so much for being with us.
Bye, thank you.
Thank you so much.
Bye, thanks again.
NOAA is probably best known for the National Weather Service, which has a long historical connection with citizen science. Weather data was one of the first types of data NOAA gathered from the public, and it's one of the most popular areas of NOAA citizen science activity today. COCO-RAS, which stands for the Community Collaborative Rain, Hail, and Snow Network, is a network of volunteers in the US and Canada who measure and report precipitation.
Being from Florida, it definitely took me a minute to realize that snow counts as precipitation. I'm more familiar with the afternoon thunderstorm variety.
Yeah, but precipitation's any kind of water that coalesces or precipitates from the sky. That includes drizzle, sleet, hail, you name it. COCO-RAS volunteers track all of this data, and it's used by the National Weather Service, city utilities, meteorologists, and more. But we'll let Melissa Griffin, Assistant State Climatologist at the South Carolina State Climatology Office, and Matthew Monet, Director of the World Data Center for Meteorology Asheville with NOAA National Centers for Environmental Information, tell you more about it. Could you guys introduce yourselves and tell us what you do?
Sure. My name is Matt Monet, and I work at NOAA NCEI in Asheville, North Carolina. And I also happen to be the director of the World Data Center for Meteorology, which was set up by the International Council of Science back in 1958 during the Cold War, when it was important to have international archives for scientific data that sort of bridged political divides. And Asheville has been serving that function ever since then. And so we have a lot of international data. So I work on lots of different data sets. And one of the data sets that I work on and that I'm the principal investigator for is it's called the Global Historical Climatology Network Daily Data Set, that has a whole bunch of different types of data from different networks integrated into it, and one of which is CocoRaws.
All right, so Matt is all about the data. I love it. Melissa, do you want to tell us a little bit about what you do and what you do with CocoRaws?
Sure. I'm Melissa Griffin. I serve as the Assistant State Climatologist for South Carolina, and I am also the state coordinator for CoCross in South Carolina. So I act as one of the initial points of contact when new observers sign into the program or sign up for the program, and then work with some of the regional coordinators and even some of the local coordinators to make sure that as observers get started, they have everything that they need, that we answer their questions in a timely fashion so they can as soon as they get their rain gauge up, they can go ahead and start reporting.
Awesome. So one thing I always like to establish is we have a pretty broad listenership, people from all around the world, and people who may have never heard of CocoRaws before. So I'm not sure who wants to take this, whoever I guess jumps first, but what is CocoRaws and how do you get started and who can get started? Where in the world do you have to be?
Do you want me to take that one, Matt?
Go for it, Melissa.
Okay. So CoCross stands for the Community Collaborative Rain, Hail, and Snow Network. It was initially established at a kind of a bucket survey in 1997 after the Fort Collins flood. It was started by the Colorado Climate Center, and just trying to figure out the rainfall that led to that devastating flood in the area. As the program started in Colorado, other states in the West started to get an interest in all these additional rainfall points. So from what started as 50 observers across the Front Range of the Rockies in Colorado has become an international science program. And it was about the mid-2000s, so somewhere around between 2005 and 2008, that the program really spread across the United States. So other states started getting on board with the idea of having weather enthusiasts at the time, now we call them citizen scientists, involved in helping monitor precipitation, so rain, hail, and snow. Across the U.S. So to get started, anyone can get started. That's one of the great things about this program. It's a grassroots program. We have people from all walks of life of different ages. We have school groups and classrooms that are, that monitor the weather and report on a daily basis. Master gardeners, farmers, retired NWS employees, current NWS employees. Just anyone who seems to have an interest in the weather is a perfect candidate for this particular program.
Wow. And just statistically, are there places you wish you had more observers? Say, boy, that's a really important place, but for some reason we don't have enough people there?
I know that every state has an area where we wish we had an observer, and kind of that data gap. And that's really where it's important to kind of foster those new observers that sign in those areas and look for observers. Here in South Carolina, we've got a couple of counties where we don't even have one observer. And I know that is kind of indicative of other states too, where you may only have one observation for a really large county too. So we're always looking for new observers. And even if an observer takes a look at the map and goes, wow, they've got pretty good coverage here, they may not need my dot. Rainfall is such a variable, value across even short distance that, two neighbors, half a mile apart can have differing values. And it's important, especially when you're looking at, the localized rainfall, when you're looking at drought, floods, having a dense network of those precipitation observations can be critical in those times.
And so the number one question I get at SciStarter is, what if I do something wrong? Will I mess up the data? So what would you say to those people who are nervous or scared about getting started?
Well, it can be daunting because you realize that the data that you're providing is going to be used by meteorologists, climatologists, emergency managers, hydrologists. But there are mechanisms to go in and, edit an issue if it exists. There is a quality control that is done at COCOROS before it's sent up to the National Centers for Environmental Information. Coordinators are usually looking at the data on a regular basis, and if we have a question about an observation, we'll reach out to the observer and say, hey, you put 8 inches. Did you maybe need 0.8 inches, or was it 8 o'clock in the morning when you made that observation? And it's really easy for us to edit that before it actually makes it into the archive. So, we're constantly looking at these observations as they come in. So we usually can catch any mistakes and correct them.
Cool. Matt, at the beginning, you mentioned, the manifold data sets you work with. Could you tell us a little bit about trends that you're seeing in data, maybe in South Carolina, as well as data nationally?
Yeah, one of the things we've seen now that we have COCOROS, because we have a higher density of gauges, the quality control of the data has actually been a challenge because there have been so many extreme events. So record rainfall, we're seeing, especially along the Gulf Coast, a lot of slow moving tropical systems. In Texas, several tropical storms where if we didn't have COCOROS, it would be much harder to really evaluate the total volume of rainfall.
And what would help you with that? I know is having a greater number of or greater density of reports. Is that going to help? Are there holes in your data where, boy, I wish we had somebody in Caribou, or I wish we had somebody here? How does that play out?
Yeah, there are still data sparse areas, especially in sparsely populated areas, as you would expect. It seems like in certain communities, the word about COCOROS gets out and you get a lot of observers. Like where I live in Buncombe County, North Carolina, there's so many climate data geeks that basically I'm a COCOROS observer. Everyone I know that I work with is. So we have a lot of gauges in our county, but there's other counties in North Carolina and South Carolina, as Melissa mentioned, where we could really use more gauges. I was just looking this morning at northern Minnesota. This pretty data sparse there, not surprisingly. But as Melissa was saying too, you can never have too many gauges. So I also give COCOROS rain gauges as housewarming gifts. So anytime someone moves into a new home, even if they're just down the street, I try to get them hooked up as a COCOROS observer, because especially summertime rainfall, convective rainfall from thunderstorms is so variable that really you can't have too many in any area. And certainly we can accommodate as many observers as are interested in joining.
Great. All right. I'm getting one. I'm convinced.
Oh my gosh, yes. I love that.
That's all I have. Unless I was just going to see if there's anything that we've left out that you guys want to be sure that we share with listeners.
I would encourage listeners to just dive in and, get used to making observations. And especially in the era we're in with climate change, the more observations we have of rainfall, the better off everyone is.
This is amazing.
Yeah.
Oh my gosh. Well, thank you so much to you both.
Yeah, thank you.
Thanks again. Have a good day.
Bye-bye.
Bye.
Bye.
So, fun fact, COCOROS is a SciStarter affiliate. So if you use the same email address for your COCOROS and SciStarter accounts, the number and frequency of your contributions will track in your SciStarter dashboard. That means that you can help monitor the weather nationwide and get credit from SciStarter for doing it.
Super. All right. So now, while weather patterns and ocean circulation are well-known areas of NOAA research, they're also active in other areas, including geomagnetism, the phenomenon that gives us the aurora or northern lights, and also that helps guide the migration of birds, butterflies, sea turtles, and other animals. Citizen scientists help NOAA study this too.
With the CrowdMag project, citizen scientists from around the world use their smartphones and the CrowdMag app to take magnetic measurements, monitoring Earth's changing magnetic field and helping improve the accuracy of magnetic navigation systems. Today, we have two members of the research team behind the project, Manoj Nair, a research scientist at the Cooperative Institute for Research in Environmental Sciences and NOAA's National Centers for Environmental Information, as well as Brian Mayer, a physical scientist at NOAA's National Centers for Environmental Information, as well as a rock star volunteer, Judy Cox, joining us.
Hey, you guys.
Maybe, Brian, do you want to introduce yourself first and tell us a little bit about what you do at CrowdMag?
Yeah, so hello, my name is Brian Meyer. I am a federal employee for NOAA's NCEI, the National Centers for Environmental Information, and I am a data manager and outreach specialist for the CrowdMag project.
Fantastic. Maybe, Manoj, do you want to go next?
Hi, my name is Manoj Nair. I'm a research scientist with the University of Colorado series and NOAA's National Centers for Environmental Information. My background is geomagnetic data modeling, processing, and also CrowdMag project, which we started almost 7-8 years ago.
Great.
Awesome. And last but certainly not least, Judy, could you give us a little bit of an intro to yourself and what you do with CrowdMag?
Yes. Hi, everyone. My name is Judy Hadley, and I live in Lincoln, Rhode Island. I'm a citizen scientist with an active interest in geology, and I've also been involved in my community for the past 22 years in groups such as the Conservation Commission, Land Trust, and the Blackstone River Watershed Council.
Wow. Thanks, Judy. So before we go any further, Brian, could you sort of explain for a layperson, what geomagnetism is?
Yeah, so as rocks are created by extruding of lava or magma, they lock in a certain magnetism based on the iron content of the rocks being cooled down below what's called the Curie point, where anything that's hotter than the Curie point has no magnetism, and anything cooler than that has both remnant magnetism and induced magnetism. So remnant magnetism is just locked in, just forever, has a magnetic signature. And then induced magnetism is a magnetism that's created by introducing these rocks through another magnetic field, such as the magnetic field created by the core field. And so the combination of this locked-in magnetism with this generated magnetism creates a magnetic signature for these rocks. And CrowdMag is one of the ways that citizen scientists can go out and look at the magnetic signatures of the rocks that surround them.
Cool stuff. But maybe really quick, if we want to back up, because let's say I'm a volunteer. I'm just on the SciStarter project finder. I come across CrowdMag's SciStarter page and I click the button to go over to CrowdMag's app or website. How do I get started? How do I participate? And I guess who can participate and where? Maybe Manoj, do you want to take that one first?
Yeah, the easiest way is to go to NOAA CrowdMag website, and there are links to Apple App Store and Google Play Store where users can download the app to their phones. Once you install the app, there'll be some permission questions and also some instructions which enables you to use the app to collect magnetic data from around you, right? I mean, we have currently an idea called magtivity, that is magnetic activity you can start. For example, when you walk around, you can start a magnetic measurements along the path. And the users also have an option to record at a certain frequency by going into the settings. And once they finish the measurement, and if they indicated that they share the data with NOAA, the app on the background send the data to NOAA's ingest servers, where we collect this data from around the world. We get about 1 million data points per month from different users around the world. And if you go to CrowdMag website and look at the map, you can see the data collected by other people and also including you.
Oh, okay. And is there sort of a tutorial or something to familiarize people with it? Because you mentioned you can set it for certain frequencies and things like that.
We actually do have what's called a tiny tutorial put together by the NOAA communications team. So if you just search online tiny tutorial and CrowdMag, it'll pop right up, and that'll give people just a general orientation to the app, but doesn't go into necessarily all the little details that some of our more advanced users could take advantage of.
Great. Can I follow up with a question for Judy? So how are you interacting with CrowdMag, and what's interesting about it for you, Judy?
Well, I guess you could say it started when I began an honors project with a geology course that I took at our local community college. And the topic that I decided to pursue is our state rock, which is cumberlandite, and it is very magnetic. So what I wanted to try to do is, based on the Rhode Island bedrock map, it shows where the boundary line of this ore body is, and then it borders another rock of gabbro and another rock of granite, which is not magnetic. So I wanted to see if I could take my phone and use the CrowdMag app and walk a certain area and see if it showed a boundary line with, the magnetic signal that came back.
Mm-hmm.
And we tried it, and I actually went up with a friend of mine who has a different type of phone. And so we walked the boundary line, and we looked at the results on her phone with the colored dots in the CrowdMag app, and it showed it as clear as day.
Huh.
And that's what, really got me going. It was really pretty exciting to see that on this app.
That is so cool. So you're not only collecting data for the CrowdMag researchers, but also kind of following an interest of your own that was more local. So Brian, for other potential volunteers, for people who want to follow in Judy's footsteps, do you have any advice on how to provide you with good, usable data?
I would say that there's really no such thing as bad data for CrowdMag. The word crowd is for crowdsourced. So we're looking to get as much data from as many people from as many locations as possible. So any information that you can send us is welcome. And we will, as the subject matter experts, do our best to clean the data, make sure it's within our tolerances, and we remove spikes and things like that, so that when we put it into our science products, we're using the best data possible. But as far as a user, there's nothing you can do to really mess up your compass or anything like that. There's really no wrong answer, and any data that you send to us is really appreciated.
Well, cool. You sort of explained this a little bit, but can you maybe more specifically say what sort of research this is used for? What scientists, different scientists learn from this?
And maybe Manoj, if you're still with us, you could take the first stab at this one. We can let Brian ring in.
Yeah, sure. So the idea of a CrowdMag started 10 years ago when we used to work with Apple and Google. They use our model called World Magnetic Model, and they use this model in the phone. So when you take the phone out, it actually points, the map app points to the north because it has a digital compass in it. And they needed this correction from magnetic north, true north, which comes from this World Magnetic Model we create within our group. So we had this idea that we work with them, and why not we take this data from them and then fit a model like World Magnetic Model. Can we create a citizen science created magnetic field model of the Earth, interior field? And we succeeded that to a certain extent. Now we are able to create a magnetic field model of the Earth purely from citizen science data to certain horizontal resolution. We are still not close to the satellite quality model. So that's the first scientific product out of CrowdMag database.
And how many more, if you had 10 times more citizen scientists, would that make a big difference?
It certainly make a difference. So we are basically looking at a trade-off between the data accuracy versus data coverage. So that means, in another way, if we can cover the whole world with the poor quality data from smartphone, but we can cover complete coverage around the globe, then we can create an equally good model. So in order to address this issue, currently NOAA has funded us to develop a flight mode. And this is especially, I like to mention this in this podcast, so the flight mode, what allows the users is to measure the magnetic data at, in the commercial plane travel, where you can put that into a airplane model.
Oh, wow. You have to sign up pilots. You have to get every pilot to join. And then just imagine.
Wow, this is amazing. So it sounds like you have some exciting things in the works for CrowdMag. But is there any other call to action for our listeners who might want to get involved from all around the world, or anything else about CrowdMag that you haven't said yet that you think people should know? Maybe Brian, do you want to take that one first?
Yeah, absolutely. I would say that you can combine your general day-to-day activities, hiking, biking, walking, running, all those things that get you out and moving that you love to do. You could do all that while contributing to science, while making our maps and our understanding of the Earth's magnetic field that much better by just turning on the app and throwing it in your pocket and going about your day and participating in these magtivity events. And you could do all that very simply, and we can't even tell you how much we would appreciate it.
Great.
I love that. Manoj, do you have any other final thoughts for us or calls to action for our listeners about CrowdMag?
So, the only thing I want to add is that the magnetic field around you is a fundamental force of the nature. And for a lot of people and students, a first measurement of this unknown or unseen field around you can happen through CrowdMag, right? Take the phone around and map the magnetic field around your place, and that can be really a fun activity, and also kind of learning this extremely important force, which in many ways shape our universe.
I love that. Thank you so much, everyone, for talking to us today. We appreciate you.
Yeah.
Good luck with your podcast, and
thanks.
Bye.
Thank you for having us.
Wow. Color me impressed by all the ways you can get started with citizen science through NOAA and explore citizen science data, too.
And whether Santa gave you a rain gauge for Christmas or not, we're confident you can find some way to better understand the weather, environmental hazards, and the world around us through NOAA's citizen science work. Find links to the SciStarter profiles for all the featured projects and more information about NOAA's National Centers for Environmental Information in our show notes.
This podcast is brought to you each month by SciStarter, where you'll find thousands of citizen science projects, events, and tools. It's all at SciStarter.org. That's SciStarter.org. SciStarter's founder is Darlene Cavalier. And thank you so much to you, the listener, and the citizen scientist for getting involved and making a difference. If you have any ideas you want to share with us and any things you want to hear on this podcast, get in touch with us at info@scistarter.org. Once again, our email address is info@scistarter.org. Thanks again, and we'll see you next time.